What is up, people? So, yeah, I'm gonna do some programming today. Why not? And yeah, so I'm gonna revisit what I was doing last time. So last time, last time I was doing this. So I was just making a Turing machine in C, and that was it. And I was satisfied with this because I even put the Busy Beaver state 5, Busy Beaver 5 onto the Turing machine, and it actually gave the right answer. So that gives me confidence that this is actually working correctly. So yeah. Yeah. So I was thinking I wanted to do this thing here. This is the next step direction I want to go in, which is this thing, algorithmic complexity. So yeah, I want to do this next. I want to see if I can, implement this, try out some stuff. I just want to get some experience with this. So yeah, I'm gonna just read this a little. So I've already kind of glanced over this paper. But I want to look at it again. I want to watch this video to explain. Okay, first let me search this up. So, algorithmic coding theory. I think it's this one. Yeah, so there's a limit to how far you can compress things. Cool. Yeah, so one thing that I want to do is research data compression, because for AI, I just think it would be interesting. I want to explore that, learn about it. Yeah, so I'm gonna read this. Okay, I'm gonna see about this. Okay, let me close this extra stuff. Okay, something I do want to do right now that I think I could be doing is making this code more robust and cleaner. Yeah, I wanted to test out a few things. Also, yeah, I gotta do a shell. Let's get out of here. Let's get our stuff. Let's tmux into here. Okay. usual. Okay. So what I want to do is make a header for this code, I guess. I mean, right now I don't need a header. Okay, my first test is I want to see what happens when I add more states to it. Okay. So let's do that. Main.c and a.out. So it still works. Let's time it. Okay. So also maybe we can. Nah, screw it. I'm just gonna type that every time. Alright, so we got this. It's busy beaver 5. Right. So I don't know. Let's do a little refactoring. Let's put T behind all these things so we can use it in our code a little nicer. So T state, T tape, T thing, T transition. Okay. T transitions. T reset. You know, and this I don't even know. Okay. I don't even know. Yeah, I'm gonna change that probably. So got this. Here it's T. Okay. Maybe T's not good. Should I do Turing? No clue. Let's just keep going. Alright. Oops. Alright. Let's just keep going. Okay, we got all that stuff. We got our here, T transitions. And these to alright, okay. I already did that. Okay. Okay. So all of these. This here. T debug. T tape. Fixed T entry. T states. Yeah. T tape. Thing. So I got that tape symbol. You know, I could have probably grepped this, like replaced all the strings with, you know, whatever they are supposed to be. But, yeah. Okay, so we got this. I see another one. Damn, I really could have used the thing. Next time I'll use it. T, tape size. Okay. Actually, this too. Alright. I suspect there's more. Yeah. So apparently this is an error there. T transition. What's up with that? What is up with that? T transition? Oh, it's this. Yeah. Oops. States. Is that how that works? Looks. Output. Oh, there we go. Okay, and let's go all the way down. I skipped that one. There we go. Okay, a little cleanup. Could have been quicker, but alas. Alright, so what I was gonna do. I don't know. I don't know what I was gonna do. I don't even think I need this reset. Not gonna lie. I don't use it. So let's just take that out. I don't use it at all. So what should I do? Let me do a test. A quick test. Instead of having T states here, what if we had something else? T states -1, for example. Still works. Yeah, it says they're incompatible. That makes sense. And it's kind of weird how quick this ran. Not gonna lie. Even though it gave a bunch of errors. I don't know. Can I help you? Can I do something here? Oh, I remember now. C doesn't support dynamic array types with the size, variable size. So if I wanted to do that, I would have to like manually do it. So yeah. Okay. Alright, let's try something. Let's try to make an algorithm that will iterate through all the Turing machines and halt after a certain number of steps, or at least just stop running after a certain number of steps, and see what happens. You know what, also, let's oh well, Busy Beaver 6, we don't even know it, first of all, so Jesus, it's very large. Busy Beaver 5 is just 47 million. Busy Beaver 6 is freaking massive. Yeah. Oh my goodness. The Busy Beaver sequence. I mean, this is wrong. Isn't this supposed to be greater? Can I search up Busy Beaver? Sort by reference. Yeah, this is the... Oh, yeah, the number of steps. Oh. So I was calculating the number of steps, and this is how many ones it can print. Busy Beaver sequence. Okay. Isn't that so crazy? Busy Beaver 6 is absolutely massive. Cool. So yeah, Busy Beaver 5. Maximum number of steps it can take on a blank tape without halting. I mean, with halting. So we know that if it takes more than this many steps and it is below 5 states, it will never halt. So that's good to know. I'm gonna use that. And so yeah, in the worst case, if I let a Turing machine run, it'll like kind of take this long to run. I want to find out, can I, oh my god, multi-threading? Dude, I could probably, yeah, I could probably do multiple threads with this. It's pretty straightforward. One of these per processor. As simple as that. How many, well, there's only 4 cores on this thing. Yeah, we only got 4 cores. So 4 cores. That's alright. 4 times faster. Almost. right? Okay, for now, I'm gonna deal with 1 core, and let's see. I'm gonna bring this back to 6, just because. Maybe it'll make it slower. Let's see. Nah, that's whatever. Okay, so what I'm gonna do is iterate over all the different transition tables that I can using my discrete math knowledge. All right, I've been learning discrete math. I can do this. Okay, let's figure this out. So let's put this here. Let's find all the transitions we can generate using this stuff. So the first thing is going to be 1 to 5. Alright, that's the first thing. The second thing is going to be 0 or 1. Right? That's the second thing. The third thing is 0 to 5. Alright, that's that thing. This is going to be a 1 or 0, and this is also going to be a 1 or 0. So this is our things here. I think we just multiplied all of these, and that's what we're going to get for that. So it should be pretty easy. So yeah, if we're considering n states, I guess, the 0th state being the halting state, so there's always going to be n plus 1 states. So this would be n states plus 1 halting state. Let's say that. So this is going to be n, this is going to be n plus 1, it's going to be 2, 2, 2. Alright, so if we multiply this out, it's going to be n times n plus 1 times 2 to the 3rd. That's how many different Turing machines we have with the 5 states, 2 symbols, and 1 tape, right? Only 2 actions. You go left or right on the tape. And yeah. So is that crazy? Probably not. Not that crazy. So we got n squared plus n. Well, actually, let's just, yeah, here you go. Wolfram Alpha. Can we get a more expansion? Yeah. So this is, okay. So this turns into this, of course. So that's how many different things we have. For n equals 5, let's put that into our calculator. What? There's only 240? Is that real? That can't be right. Right? Did I do that wrong? Let's put this back. Well, it's the same thing. I mean, come on. This is 1 to 5. Right. This is gonna be 0 or 1. Right. This thing is gonna be from 0 to 5. Right. This is gonna be 0, 1, and this is also gonna be 0, 1. Right. This is 5 times 2. Right. 5 times 2 times 6 times 2 times 2. I mean, that has to be right, you know. It's 240. I thought it would be more. Is that seriously? That can't be right. That can't be right. Oh, look at that. Yeah. There's a lot more. That's... What did I do wrong? That's so silly, guys. How did I not get that? What is it, permutations? It's with repetition. Oh, yeah, duh. Let me look at it again. I still don't get it. Okay, so you say each of the machines have 10 transitions. That's correct, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 transitions. And each transition has 240 possibilities. So, is that? Oh yeah, because this is per transition, and there's 10 transitions, of course. Did I calculate that right though? Because he said there's like 24. I got 240. He did 5 states plus the halt state times the symbol to wire it to times the direction. But I also included the right. I mean, I included a write where it writes to the tape. Is that? What happened to that? Is that? Because this is the right thing. These right ones. This is a 0. And this would be the next. Hold up. What did I actually do for that? It's state symbol, next state, right. So next state, right. Yeah. So yeah, this is the next state. This is what it writes. This is the action. So this per transition, there's 10 transitions. You know. There's 2n. It's to the power of 2n. Cause yeah. Did I? So what about writing? I don't think he talked about writing. So they specify a variant where it has no shifting. So I want to do the busy beaver, one. So hard, nice. It's a nice problem. So yeah, they don't include the none shifting. What about writing? Is that a... That's... They don't talk about that. Is there like an action type thing? Let's just look at the Turing machine. Let's look at your standard Turing machine. Okay, let me just look up busy beavers and yeah, let's see. Yes, it produces 3 outputs. A symbol to write over, a direction to move, and a state to transition in. That is in the code. That's these 3. These 2 encode the current non-halting state and the current symbol, which is these 2. That is the transition function. So based off of this, how many busy beaver Turing machines are there? End state busy beavers amount. I just want to see how many there are. Like, how many are there? Oh yeah, okay, here we go. So we got Turing machines. Look at that, he made a little thing. That's cool. So he got this. Yeah, we got a similar result. I got 8 instead of 4 though. So I don't know what happened there. Wait, no, it is 8 because it's to the 2. So okay. Yeah, so let's just keep track of this, all this stuff. So that's a lot. Yeah. So let's see here. So 4 times 5 plus 4 squared is 576, which is pretty large. I got 240. What am I doing, bruh? So it says to find this, we might consider using a process. Nah, I'm just gonna keep trying. Or not, you know, screw it. I have to keep trying because I need to find a way to permutate through all these. So this is our yeah, screw this, bro. Screw this. I don't really care about this. I just care about this. This is what we're generating, permutations. So yeah, we're gonna have to generate the permutations for this. So to do that, we permutate through this, permutate through this, permutate through this, and you know what's crazy? There's 10 of these. So oh my god, that's gonna be a lot. That's a lot. So it's just a string of 10 of these. That's what we're permutating. So okay. So I'm gonna call this single transition. Right? It's one of these strings, and then a transition function, right, equals a single transition to the nth power. In our case, 5. So, I mean 10. 10 of these. 2 per transition. So, yeah. That's a lot. That's a lot of transitions. Holy moly. Let's see. Because what I want is to like find a Turing machine that generates like a specific string that I want, but yeah, that's tough. That's tough. Let's see. can I do that? So if I have a tape, let's see. What if I modified this? So instead I had like I don't know. Bro, I don't even know what I want to do. I think I just want to enumerate the Turing machines for state 5 states, and then see if we can do anything useful with them. Maybe compress some data, you know? So, oh my god. I mean, this is a huge number right here. It's like a freaking huge number. Dude. 240 to the 10th is a large number. It's a large number. Yeah, bro. That's a lot of Turing machines. I know, you know, I have a method to determine if they halt, and that's because I know the Busy Beaver number on a blank tape is going to be this many steps for 5 states. But yeah, that's kind of tough. Kind of tough. All right, I think the first thing I'm gonna do is make some sort of compiler for the Turing machines so that you can input a string and it will give you one of these. Like it just maps to one of these. So it's just gonna be straightforward. Pretty straightforward. So yeah, let's see. Yeah, it's just straightforward. Alright. So you just give it a list of things. What if I make a struct that has in it an array of like it's a struct, you know? Like there's a transition, and then we have an array of structs for oops. Yeah. So let's see that. Let's see that in action. Let's call it trans function. And you know, I think it'll just be this. It's just this. It's just an array. Okay. Okay. I could make a type def for that, actually. Much simpler. Let's look at that for a second. So, okay. So I'm gonna make a type. Screw this type. Screw this motherfucking type, bruh. Screw the motherfucking type, bruh. Nah, don't screw that type. Don't screw the type. What the hell am I even making? Let me just try this. So, load transition string. So instead of making your making it with you know, instead of making it with freaking I don't know. I just want to be able to encode it with like a string, so we can iterate through all the strings. That would be like that would be pretty nice, I think. You know, all the different permutations. You know what? Let's look at that. Let's look at that. Let's generate the permutations. Oh, and they have a complexity. Yeah, brute force. This uses JavaScript. Heaps algorithm? What the heck is that? Mr. Heaps algorithm. So yeah, generating permutations. First, let's do this string thing. So this is gonna be an array of 5. Pretty simply. Transition entry. I'm gonna call this trans definition or something. Alright, I don't know. This is the transition itself. Is it? I don't know what the hell I'm calling this. Whatever. I don't know. I'll call it transition string. How about freaking that? How about freaking that? And what it's gonna be is a char of 5. Easy as that. Or states. Char states. No, it's just 5. Just 5. This doesn't even have to be. Nah, it could be char. Yeah, as long as the states are under like a large number, then this could work. So I think that's good. If I even wanted to, I could make it into integer. Then this could be really huge. So that's cool. That's good. So this is a transition entry string. I'll call this a transition string. And then I'll put here states times 2. This is a transition function string. So easy as that. So that's what we get. Okay. So, okay, that's what I'm working with. I'm gonna put that here. And it's gonna be states minus 1. Because states is always including the halting state. We don't really include that in our transition thingy. So yeah, let's try to compile this, see if we type, yeah. Is there a problem with this? Did I use type def incorrectly? Come on. God damn it. Get out of here. Alright. Maybe it's this one. Why is this an error, bro? It's really an error? Oh. Do I put it here? Yeah. Interesting. So I guess I'll be using this. Apparently. It's probably a very bad idea. The resulting type is an array type, but users of it won't see that it's an array type. If used as a function argument, it'll be passed by reference, not by value, and then the size of for it will be wrong. Probably want to use unsigned char also. Okay. Okay, that kind of makes sense. So we have print by pointer, and then so I mean, all right, I'll freaking use this properly. I guess. And then this one would this one would have that many states. Yeah. Yeah. Alright, let's see. Oopsies. Did it twice. Okay. Awesome. Super awesome. Redefinition. Is it because I put this here? States undeclared. Oh, my bad. I think I messed this up. Oh yeah, whoops. Silly, silly, silly. Okay. Okay, well it compiled. Thank the lords. Maybe I could make it a little nicer. Okay. My goodness. Alright. So this would be passed by value, I'm assuming. Passed by value. So in here you would load what I want this to do is that I could convert this right here into, like, I could feed, instead of having to call mset transition 10 times, I just feed it one string, and then that would be the same thing. Okay, I'll call it a string. Alright, so alright, let's call that load transition function string. Excuse me. String. Okay, so this is pretty simple. You just loop through it. Okay. Right. You just loop through the all the strings, and then you load the thing, I guess. Is that how that works? Right? You just go through the string and load all the stuff. Alright. So you would say the string dot x dot x again. Okay. And then you would have, this isn't even a goddamn string. I wanted a binary, I wanted just a single array. Nah, this is good. I think this is better. Because we give it like structure and this is could be better. Yeah. The transition itself, I already have it to include all this stuff. Okay. Whatever. Dude, this is so dumb. This is not what I wanted. I want a string. Why do I keep going back? Oh my god. Alright, this is my goddamn... This is the string, bro. This is the string. Okay, it's gonna go like this. Okay, it's not a struct. Freaking integer array. Go like this, times 5. That's it. This is literally... Oh my god. This is it. There's no more crazy stuff happening. It's literally just an array. Oh my god. Let's call this you know what? I'm just gonna do this. The dude on Stack Overflow said this was bad. I'm just gonna do it anyways. See whatever happens, bro. Let's just see what happens. It can't be that bad. It could be. but it could also not be. So I'm gonna call this function string. All right, and let's just hard code this right here. It's all hard coded. Okay. So this ain't even it, Chief. This ain't even it. We gotta increment by 5. Increment by 5. Okay. Is that what we do? We increment by 5. Yeah, that's what we do. Yeah, that's what we do. Okay. Int I equals 0. I is smaller than something. What the hell am I even doing? So I have I for, I should probably do states, right? States. And then okay, so I have states, and then what do I do on this one? For each state, there's 2 transitions. So erase this. There's 2 transitions. One for this one for that one. Right? So yeah, let's also, I think you're supposed to put the thing here. The transition function, right, has to be a thing. So yeah, let's include that here. That's a very large, that's a lot of code. That's a lot of code for one line. Oh my god. That's because I put the whole thing. Alright. Yeah, this probably could be a type def right there. I might actually use that. So type def, and I'll call this trans table. Alright, transition func table. So we can tell the difference. This is a table. This is a string, and the table is gonna have this stuff, and it's gonna be this right here. So yeah, we can now just do this. Table. This is the function. This is the function table. Alright. And then if this works, I will rewrite. I'll replace this with that type. Yeah, so we got that. So what we do is we iterate through all the stuff in the string. And how the string works, it's gonna be this. It's gonna be this. All right. What I'm gonna do, which will be easier to implement, is it should probably just go in order. I don't know, bro. Let's take a look-see look here. Like, for example, let's get this transition, right? So this transition, we include these two. I might as well include it, that thing. So the only reason I'm talking about this, trying to decide how complicated to make like this string function, string language thing, and I don't know. So here's what I'm gonna do. Each 5, it's gonna read 5 numbers at a time from the array, and it's just gonna do it in this order, where it's gonna say state, symbol, next state, write, and action. So that's what each thing will be, and there's going to be a number of these. So I'll say there's more than one, and that's it. So yeah. So yeah. So yeah, so here we go. So function string I is gonna be the state, right? So let's just do that. And then symbol, it's gonna be I plus 1, right? Then next state, it's gonna be I plus 2, and the right is gonna be I plus 3, and then the action is gonna be plus 4, and then what we do is we do this, and on here you put the table, and then you put the state, symbol, right? Now you put the next state, and the right, and the action. Yeah, so that's what we're gonna do. That's what we're gonna do. Easy enough. And I think that's it, actually. I think that's it. So yeah, that's it. So yeah, instead of doing this a bunch of times, we only have to supply these numbers, which should make it quicker, right? And so yeah, instead of doing this, let's try to do a busy beaver with this to make it a little quicker. So okay, I'm gonna grab all this. Okay, go to Notepad. Oh, look at that. There's a bunch of trash in here. Alright, that's cool. That's cool. Let's get a cleaner. Okay, that's whatever. Whatever. Let's just continue. So let's call this init new, and I'm gonna put this right here. Okay. Okay, and what I will be doing is copying this. Okay, and copying that. Okay. And now I can do this. I'll see how this works out. But yeah. So I put the table, and then I put the string, which is really an array. It's just an array of integers, right? And now I just start typing. So, just start typing. So let me get this here, bring this all the way here, a little bit like that. This looks like super crazy. Oh, it's lagging. Can I select multiple? I want to clean this up a little, you know. Let's just clean it up so we can zoom in at least. I want to be able to see all the. There you go. Oh my goodness. Alright, almost. Okay, let's get everything down all the way. This is a little better. I have a better idea. Why don't we get this here? And go like this. And let's not see all the characters now. Okay. And there we go. I didn't have to erase all that stuff on the right. I could have just done this. Okay. And of course we got random stuff here. Lovely. Happens every time I zoom out and in. Okay, so it'll be 1, 1, 3, 1, 2 left. That's our first entry. Okay. Now I can do the second entry. We got 1, 0, 2, 1, 2 left. 1, 0, 2, 1, 2 left. It's actually 2 right. Okay. So yeah, there's 10 of these, so 2, can I just, yeah, there we go. Copy, copy, copy. We gotta reuse the code, guys. Gotta reuse the code. And this is, we're doing this so we can eventually iterate through all the Turing machines, but like in an easier way. Like the strings, I want the strings to be like easier, you know. Oh. Look at this. Okay. Alright, so this is complete. 1 1 1 0. Why is there a 1 1 in the beginning? Is that, does that seem off to you guys? 1 1. Is it supposed to be 1 0? That's odd. That's right, right? Because it's 1 1 3 1 left. 1 1 3 1 left. 1 0 2 1 right. So this is still correct. Oh, I switched.